two bodies of mass m, let this be A with mass m and let this be B with mass m, are moving with velocity v, v1 and v2 respectively. So they had a perfectly inelastic collision. We need to find the loss in energy in this collision impact. So from conservation of linear momentum we can write m times v1 plus m times v2 is equals to m plus m times v dash. So v dash is equals to v1 plus v2 by 2. We need loss in energy, so let the kinetic energy of system before collision be ke1 and after collision be ke2. So ke1 equals to half m v1 square plus half m v2 square. ke2 is equals to half 2m v1 plus v2 by 2 whole square. So if you want to find the loss in energy, so delta change in energy is equals to, that is ke1 minus ke2. This much amount of energy is lost to the surroundings. So let's calculate this. Half m v1 square plus half m v2 square minus half m by 2 v1 square plus v2 square plus 2 v1 v2. I got this 2 outside, so it becomes 4. So this will be m by 2, and from this we can take half m as common. Half m v1 square plus v2 square minus v1 square by 2 minus v2 square by 2 minus v1 v2. So this will turn out as half m v1 square plus v2 square minus 2 v1 v2 by 2, which will be equal to 1 by 4 m v1 minus v2 whole square. So this is the amount of energy lost to the surroundings due to the inelastic collision between A and V.